Okay, we're going to start solving a system graphically. Basically, what we can have happen is when we're solving systems, we can either have one solution, which would be one coordinate point, or we could have no solutions, in which case both of the lines would be parallel and therefore never intersecting, or we could have infinite solutions, meaning the lines overlap each other and they intersect at every point on the line. So what I've done here is I've gone and turned both of these lines into slope-intercept form because it is the easiest to work with. We can also check our answer in the calculator when we get there. So there you can see all of the steps that I've already taken to solve for y for each equation. So what we can do now is I will graph we'll graph y1 where we have an intercept of -4, and I'll use the slope to find the next point, which would be a rise of a run, a rise of 1 and a run of 3. So a run of 3 and up 1 would be right there. So right now we have our first line. I'll try to draw this as straight as I can. Okay, and on the other line we've got a a y-intercept of 2, which would be right here, and we would have a rise of -5 and a run of 3. So I'll count over 3 and go down 5. 1, 2, 3, 4, 5. Okay, so what we can see is going to happen here okay, we can see very clearly where on this graph we have an intersection. Alright, and therein lies the solution. We have an answer here of 3, -3. Okay, and there's a couple things you can do to check this. You can check this using algebra, meaning you can plug in 3 and -3 for x and y, and you should get a true statement. For example, if we looked at this equation right here, we said 3 minus 3 times -3 equals 12. We should get a true statement. So 3, this is going to be plus 9 equals 12, and that is true. Okay, and you can do the same exact thing for the second equation of 5x minus 3y. What we're going to do now is we're going to go ahead and plug this equation into the calculator. Let me just make sure we can get this. Okay. Okay, so what I'm going to do now is I'm going to graph the both of the equations in my calculator. So I'm going to put 1/3, 1 divided by 3 times x minus 4, and the other equation I had was, I believe, negative parentheses 5/3 x plus 2. Now if we graph this on the standard window, again we should see the points -3 and 3, -3 come up as their intersection. Now our graph looked very similar to this, so hopefully we're on the right track. Now what we can do is check our answer and get an exact intersection here using the calculator, and this is a function you're going to need to know, and we're going to be using again and again throughout the year. So we're going to hit second calc. I'm going to scroll down to intersect. Right? Normally what I like to do is I like to get close to that intersection, but most times if you just have two lines on the graph, you can just hit enter 3 times and it'll come up most times. I like to get closer to the intersection if possible. Okay. Using the graph, pencil and paper, what we found was our intersection happened to be on 3, -3, and in this case with the calculator we've done the same thing. We've gone ahead and plugged both equations in after solving for y, plugged them into the calculator, graphed it. Then what we did was hit second calc, number 5 for intersection, enter, enter, enter. And you can see here on the calculator the intersection is x equals 3, y equals negative 3. And what that means is both equations are equal to each other when x is equal to 3. Alright, there you have it, solving systems graphically.